Exercise 7 of Chapter 2 of Anderton's Elements of Set Theory. Part A says, show that for any sets A and B, the intersection of the power set of A and the power set of B is the same as the power set of the intersection of A and B. And Part B asks us to show that the union of the power set of A and the power set of B is a subset of the power set of the union of A and B. It further asks, like in the last question, under what conditions does equality hold? Let's do this the usual way. So we want to show first that the power set of A intersect the power set of B is a subset of the power set of A intersect B. Pretty straightforward. Let's just do what we always do. Suppose big X is in the power set of A intersect the power set of B. Then X is in both of the sets, the power set of A and the power set of B. Thus, X is a subset of A, and X is a subset of B. So for all little x in X, little x is in A, and little x is in B. Therefore, little x is going to be in the intersection of these two sets. So what this tells us is that if every element little x of big X is in A intersect B, then big X has got to be a subset of A intersect B. And thus, X has to be in the power set of A intersect B. And then we conclude that the power set of A intersect power set of B is a subset of the power set of A intersect B. Straightforward, about as direct of a proof as this book can offer. And the converse is pretty much the same. Let me just add 2 pages just in case. Converse is pretty much just the same. So we want to show now that the power set of A intersect B is a subset of the power set of A intersect power set of B. Why is it so hard to write? Okay. So again, let's suppose big X is in the power set of A intersect B. Okay, just double checking them, not proving the same thing twice. Okay. Then, by definition, X has to be a subset of A intersect B. And thus, for all little x in big X, little x is in A intersect B, which means that little x is in A and little x is in B. What does this tell us? This tells us that X is a subset of A and X is a subset of B. So X is in the power set of A and X is in the power set of B. So it follows that X is in the power set of A intersect the power set of B, and thus it must be true that the power set of A intersect B is a subset of power set of A intersect power set of B. So, power set of A intersect power set of B is equal, indeed, to the power set of A intersect B as desired. Okay, fantastic. So, yep, about as straightforward as these proofs get. And then for B, they ask us to show that the power set of A union power set of B is a subset of the power set of A union B when does equality hold? In my opinion, this is a lot easier than question 6, but again, difficulty of math is subjective. All we can agree on is that math is difficult. So, again, suppose x, let's just prove this. Suppose x is in power set of A union power set of B. This means that x is in either the power set of A or x is in the power set of B. What this tells us is that for all little x and big X, little x, sorry, I skipped a step. Let me go back. So either x is a subset of A or x is a subset of B, or both. So for all little x in big X, x is in A, or little x is in B. Regardless, little x has to be in A union B. Therefore, x must be a subset of A union B. And thus x is in the power set of A union B. And it follows that the power set of A union the power set of B is a subset of the power set of A union B. Again, I'm going a little bit fast because this is just repeating the same structure of proof of simply considering any arbitrary element within the set that we're trying to prove is a subset of the other, and then just kind of breaking it down based on the definitions of the power set or the union and all that stuff, um, until we find that inevitably whatever set you pick, whatever element you pick from here also has to be in here. I encourage, if you didn't follow along, rather than rewatching the video, I encourage you to try it out yourself, and then if you get stuck, just watch and see what I do. But hey, this is your math, not mine, so just have fun with it. That's my only advice I can give you. Okay, and now for the second part of the question. When is it true that the power set of A union the power set of B is equal to the power set of A union B? Well, since we know that I'm just going to write out what I'm saying. Since we know that power set of A union the power set of B is a subset of the power set of A union B, we just need to determine when the power set of A union B is a subset of the power set of A union the power set of B. So let's just try to do the proof as we would normally. So suppose big X is in the power set of A union B. So big X is a subset of A union B. Thus, for all little x and big X, little x is an A union B. This means that little x is in A or little x is in B. Right? And now what we're trying to show is that this somehow leads to either x being a subset of A or x being a subset of B. Now, let's consider all possible cases. So this statement right here is true if x is in A, but x is not in B, x is in B, and x is not in A, but x is in B, sorry, or x is in A and x is in B. So what does this mean? This means that we can take any of these individually, or rather, I'm sorry, this is not how, this is not, I got confused with a different question. Okay. One thing we can do is try to think of a Venn diagram, and this is simply a visual representation of the two sets. So let's call this one A and let's call this one B. Now, the thing is, we can have a couple cases, right? I'm just going to color them in. So what would it mean for X to be in the power set of A union the power set of B? This would mean that either X is a subset of A or X is a subset of B. And this happens when X is neatly contained within either one of these two circles. So I'm going to draw three different X's. So this X, call it X1. X1 is a subset of A because, as you can see, everything contained within X1 is also contained within A. X2 is also a subset of A, clearly, for a subset of B for the same reasons. And then here, let's call this one X3. X3 is actually a subset of A, and X3 is a subset of B. But there's also a different case, right? If X is in the union of A and B, then the elements in X can be spread out throughout anything. So something like this, for instance, I'm going to call this X4. X4, sadly, is not a subset of A, and X4 is not a subset of B, right? So what this tells us is that for some X to be in the power set of A, power set of A union B, for that to be a subset of A or a subset of B, then we need to find out a way to get rid of this case right here, where X is not a subset of A and X is not a subset of B. Now, the most straightforward way to do this, and I challenge you to show that this is in fact the only way to do this, is to consider when this is your A and this is your B. In this case, what do we have? Oops. In this case, we have that if X is in the union of A and B, then it has to be somewhere within this circle. And no matter what you pick as your X, this can be X, let's call it X5 or X6. No matter what you pick, you will have that. Even if X is not a subset of B, X is necessarily a subset of A, right? But of course, this can only be true if B is a subset of A. Or conversely, we can just swap the labels and say that this one is B and this one is A. So A subset of B. So to put this all together, the power set of A union B is a subset of the power set of A union the power set of B if A is a subset of B or B is a subset of A. Now, we can prove this, of course. So suppose A is a subset of B without loss of generality. And it's without loss of generality going from here to here, because proving the case where A is a subset of B and proving the case where B is a subset of A is the exact same proof. So then if X is in the power set of A union B, then X is a subset of A union B. So for all little x and big X, X is in A or X is in B. But if X is in B, if X is in A, then X is in B. Since A is a subset of B. So for all little x and big X, little x is in big A. This means that big X is a subset of A, which implies that big X is in the power set of A, which implies that power set of A union B is a subset of the power set of A union the power set of B. With the condition that A is a subset of B or B is a subset of A. And that's it. That's all there is. Those are the cases under which this holds. I encourage you to try to show this one on your own. It's a very straightforward thing to do. I hope these diagrams are helpful. I'll try to do more visual stuff like this in the future. But aside from that, that is the whole proof. That is all for this video. And I will see you in the next one. Bye bye.